You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Uptime Podcast. On today's episode, we are going to cover a couple of really interesting animal-related airport issues. Number one, a poor brown bear got struck by a 737. So we'll talk about that. Wasps in Australia have been actually wreaking havoc also on 737s and their pitot tubes. And we'll also talk about a lightning strike that prompted a New Zealand aircraft to divert. So, keeping up with some recent lightning strike news. In our engineering segment, we're going to chat about some interesting aerodynamics on props and some aerodynamic stuff there. We're going to talk about a interesting new Bell rotor, tail rotor concept. And lastly, in our EVTOL segment, I know Alan has some pretty interesting thoughts on Uber Elevate and just the scope and the future of their business, because there's a lot of stuff that seems very nebulous, and it's starting to sound a little bit like maybe some, as Scott Galloway, the business professor, would say, yoga babble. So, Alan, let's first talk about this bear strike. So that seems, really hard. How did the bear get on the runway? But also just really sad. Bears are super cool.
Yeah. Well, it's up in Alaska, and they had a brown bear and a cub crossing the runway as the 737 was landing, and there's really not much to do about it. And it acted like the pilot didn't even see it, obviously, or would have gone around. And it's an occasion you see things about aircraft striking deer, right? So a deer is a slightly taller animal, tends to be, and aircraft hit those too. There's a lot of, in today's world, there's a lot of periphery fences around airports because of 9/11. So there's not as much wildlife walking around on runways, but still wildlife gets in. And if the bear's going from point A to point B and the runway's in the way, they're going to walk across it. And in this particular case, it just hit the inlet on the engine and dented the inlet. And obviously it killed the bear, which is just a bad situation. So I'm sure everybody just feels horrible about the whole thing. That I'm sure passengers saw it. It just doesn't. There's nothing good about it, right? Yeah, it's like, well, what are you going to do?
They said the cub was unharmed. Yeah, not a poor guy, but poor gal, mama bear.
Yeah.
That's terrible.
I've seen cattle on runways. That happened here locally one time. There was a cattle had gotten loose, and our local airport didn't have a surrounding periphery fence at the time. So there's cattle on the runway. Thank goodness an aircraft wasn't trying to land, because that would have been a real mess. But you just got to be aware of that. And runways are not like any different than a road. And you see deer on the road, there's deer on runway. And in Alaska, there's bear on the runway. And Canadian geese, right? We all know about the airplane landing in the river, right? So aircraft are around wildlife a lot more than you think. And if you actually go look at the number of interactions between aircraft running into some animal on the runway, it's a lot. It's a lot more than you'd think it would be. So everybody's got to keep their eyes open. I think Alaska is one of those places where you probably have to do it a lot more, because it's just a lot more wilderness there than you'd say in Newark, New Jersey.
Yeah. Well, and looking at this Alaska airliners, obviously the 737 is not that big of an aircraft, but it only seems like so many parts are close enough. Like I was looking, I'm like, what hit this bear? Obviously you said it hit the the lip of the engine, but it could only hit the wheels and that's the only, it couldn't possibly be tall enough to hit the nose.
No.
So,
oh gosh, no. I hope not.
Yeah, maybe a moose. A moose could.
Oh, a moose would do a lot of damage. Right.
Yeah.
That would do a lot of damage. And I bet you if you go back and look at flights in Alaska, somebody's probably hit a moose. It's just one of those things that you just can't control unless you really have a good perimeter security and a fence where they can't hop over or crawl underneath. And if they can, they're going to be out there. It's hard.
Yeah. Well, so the next article I'd like to discuss is about Australian wasps. So these mud dauber wasps have apparently been blocking a lot of pitot tubes, and that seems much more difficult. Like for me, I'm kind of like, well, you know what, just make a better perimeter fence for all the money we spend on security. That seems relatively control to keep bears, and like bears are not small.
No.
But these wasps, and obviously I understand birds are just, you can't control the airspace from birds, but These little wasps are plugging all these tubes, and why is that such a big problem?
Well, the pitot tubes tell you your airspeed, and it's always a problem wherever there's wasps or hornets that like to make nests, especially the mud daubers, because they make their nests out of mud. So they're actually bringing in dirt with them to create a home. And if you've been around a wasp nest or a hornet's nest, those little honeycomb slots that they like to live in, so it gets really difficult if they see a nice little opening or a hole, like if you have one on the edge of your roof of your house. There's always wasps up in there. Like they'll find those little cracks and crevices to go make a home in, and pitot tubes can be the right size to make a home inside of. And especially on a 737, the pitot probes aren't really close to the ground, so you can't put your eyeballs on a look inside of them. On a smaller, like a Bonanza or a Cessna 182 or something of that sort of smaller aircraft, a personal aircraft, you look inside those pitot tubes to see if there's critters crawling inside, and you have them covered when you're not flying the aircraft to keep the critters out. But on a 737 that sits out overnight in Australia, you really can't tell. And so you may have hornets and wasps crawling up inside there and trying to make a home. And if you don't know what your airspeed is, that's a big problem, right? Because aircraft, you really need to know what your airspeed is to fly the airplane properly. And if it's got some sort of blockage in it, you got a world of hurt. Now, the article was really interesting because it was like a study done over a number of years about that impact. And was it like more than 50% of the cases were on 737s? Like they don't like the Airbus. So they don't like
56% of them were on the Boeing 737. Yeah.
That's a crazy number.
And then the A330 after that was about 20% of them. But yeah, it's just got to be just the right diameter, like you said. Like obviously they're not going to nest in something that's huge when they're, the size of a finger.
Right.
So they just really like the 737 tubes.
But wouldn't you figure that if you're designing those pitot tubes that you would at least take that piece of information back and then do something that would prevent that? Because it's a serious thing. Not knowing your airspeed is a big deal. The whole AOA issue with the 737 and MCAS system, right? It's a sensor problem. Well, you got insects causing sensor problems that have to do with airspeed. Those are big problems. And one of the things that has hurt aircraft over time is when they do put those red sleeves. I don't know if you've ever seen these things. They say remove before flight. It's got a little tag hanging off it. And they slide it over the pitot probe. You're supposed to move before. People forget to take those off and have had accidents, even though they're red and they're dangling out there and they're noticeable. Well, you're never going to notice a hornet's nest up in a pitot probe on a 737 until it's too late, right? Wow. Scary.
Yeah, just goes back to we talked about in multiple shows before, just that checklist. Like you just got to go through all, like look inside every pitot tube, or pull off the red covers, like you said. Just little things like that are easy to get missed if you just don't check off every item in your list.
Oh yeah, and Australia is just a tough place already, right?
Yeah, you like spiders the size of just like stalking you in the night. It's terrifying, all the creatures in Australia.
Oh yeah, don't they have the highest number of poisonous creatures, or at least creatures that can kill you?
That sounds right.
Australia? Yeah, right. So just the you got to be a hardy
Freddy Krueger lives there too, and Jason I think now vacations there.
Oh my gosh, yeah. Well, it's
all
just
the
one of those
frightful
things.
Creatures.
Right. It's just one of those things about Australia. Like, man, they're pretty tough down there, right? And but at the same token, I think we should be taking some of that data back, especially if you're designing pitot probes and making them a little more insect resistant would be a good thing to go do.
Yeah. So lightning strike prompted a New Zealand Air ATR 72. So this is from simpleflying.com. And this is a pretty in-depth article just talking about lightning strikes in general, not just quickly reporting this one incident, but I mean, a bunch of stuff out of obviously that part of the world. Is New Zealand heavy lightning area, or I mean, what about this article sticks out to you?
Well, I think Australia and New Zealand are prone to some decent number of lightning strikes, and it's probably just the way that where they're flying to. They're running across storms quite a bit, and they have a lot of lightning strikes there. You read about strikes in New Zealand and Australia quite often in the press. I see them all the time. Where the United States and in Europe they're having roughly the same number of strikes, or you'd think that they would, but maybe the strikes are just more severe, or they're just more aware of them in the Southern Hemisphere, something of the sort. Because you see a lot of reported lightning strikes on aircraft, and the summary is pretty much the same for most of those reports, and which is very good because the United States, I think, reporting is garbage for the most part if it's just a general reporter. But in Australia and in New Zealand, they have a description. The aircraft are designed to take lightning strikes, and lightning strikes occur roughly once a year to most transport category aircraft, and everybody is safe. There's a Faraday cage on the airplane. All that stuff is true. So it's a really good reporting that they have that we just don't seem to have in the United States. But I think it's fascinating to read an article that's a sort of general purpose article has correct information in it. So it's nice to see. And obviously the airlines in New Zealand and Australia are very cognizant of inspection criteria and repairs that have to happen after having a lightning strike. So they seem to be doing all the right things, which is really, really good to see.
All right. So in our engineering segment today, first up on the docket is some interesting wind tunnel technology. Have been testing some new propellers. So, Alan, why don't you start us off here? So what did you notice about this article from aerospace-testing-international.com?
Well, you don't think about testing propellers anymore. That basically since after World War II, there hasn't been a lot of propeller technology, so to speak. Obviously, they're making them out of composite materials, and they seem to get more aerodynamically shaped over time because we have the computational power to go do it. But to actually put some really a good amount of effort into propeller shapes to reduce noise, right? Propeller noise is a big deal. And I thought, well, maybe the propeller industry is going to get it revitalized in some sense. All the eVTOLs are all propeller driven, and there's a lot of propellers on each one of those aircraft. So maybe there's a new frontier in propellers, and it's good to see at least that sort of fundamental research going back in, because as you've seen, Dan, a lot of the articles about the eVTOLs is about noise.
Yeah, it's a big issue. Yeah, because if these are getting closer and closer to cities and actually doing the air taxi job, it's got to be quieter. I mean, think about how obnoxious it is to be anywhere near a helicopter. I mean, it's just got to be really quiet.
Right. I think it was Wisk. I was watching the video from Wisk the other day where they were comparing their aircraft to a helicopter, and they had a helicopter a certain distance away and how much noise it was, and then their aircraft comparable. Obviously, there's a huge difference between the two. A helicopter is just plain old noisy, but the electric aircraft is a greatly reduced noise just because of the way that the propellers are set up in the electric motor. But if they can actually lower that down even more, don't you think there's more applications in closer to the city? Like I think Los Angeles is one of those places they just don't like helicopters, and New York City doesn't really care for them all that much either. But if they're quiet, who cares?
Mm-hmm. Yeah.
It should open up those markets in which they otherwise may not be able to get into. So at least, you remember reading the article from Beta Technologies on their aircraft where they were making their own propellers, right? That's one of the things they did to save money early on. I think they were making their own propellers. And making a propeller is not a basic fundamental propeller is not necessarily rocket science, but making it quiet is. It is a lot of science involved in it. And I kind of wonder, at what point are they going to start everybody's going to really start to switch over to these much quiet propellers, even in an electric aircraft. Is it going to be driven to make it as quiet as possible? And if the technology is there and we're capable of making it, which we clearly are, then you almost wonder on the regulation side, you're going to see the regulations push them to be quiet, which will force them into some of these new propeller designs. Could happen. It really could happen.
And so, I mean, why do we need more actual wind tunnels and these anechoic chambers and stuff like that? Why can't we do it all, digitally now? Are we still just not there yet?
You can, but it's complicated. Anytime it's just like on our winter podcast for uptime, the complexities of a propeller falling into the wake of the previous propeller causes difficulty. And you got this, the propellers create their own little environment for airflow. So that can be really tricky. And the noise coming off of the propellers can be tricky. It's a little hard to predict. And that's why they're still in wind tunnels doing some of those measurements, because computationally, you're really learning from the experimental data, empirical data, and then putting it into the computer to try to represent that, because it's just so complicated. But I think with the well, we're seeing it on the wind turbine side. So on the wind turbine side, you're starting to see some more of that information come in, and they're looking at the wakes on the previous blade and how it influences the blade behind it. Well, wind turbines aren't moving nearly as fast as propellers on an aircraft, so the complexity just goes way, way, way up on an aircraft because of the speeds. So it's just difficult. It's really difficult, as you can well imagine.
So Bell is working on an electrically distributed anti-torque tail rotor that they think can potentially replace traditional ones. Alan, looking at this technology, does it seem feasible that they can actually do that?
Yeah, I think we're close to doing that. Now, the Bell design had 4 separate little fans with electric motors driving that. So the efficiency is it's not quite there, it seems like. But simplicity-wise, an electric motor is, well, and maybe this is related to failure modes. If I had one big motor and that dies, then I can't keep my helicopter from spinning, right? It's an anti-rotation device, anti-torque device. So I have trouble. So I'm breaking it into 4. If one of them goes away, I still have enough to get home with. And maybe that's the thought behind it. So maybe there's some system safety aspects in which came up with that particular design, but it's slick, right? Because on a baseline helicopter design, you have the main rotor, and then you have a drive shaft that goes to the back end to the tail rotor to drive the tail rotor. So you got this big sort of transmission system and these tubes, drive shafts that are in there to do all that. If you can take all that weight out and have an electric motor do the same thing, then you save a bunch of weight and complexity and get the same result. So yeah, it makes a ton of sense to do. And years ago, I think it was Bell or McDonnell, had instead of a tail rotor, they had basically the exhaust blowing out and a sort of a fan-like feature or exhaust port sort of. That was the anti-rotation tail rotor replacement, which is pretty cool. So it's like a jet-powered tail rotor setup, and that was complicated because you're using hot air, and they had this rotating mechanism, which was complicated. So I haven't really seen that. I remember that doing flight tests with that, but I haven't really seen it in production anywhere. I haven't seen that aircraft anywhere. But this electric tail rotor thing, it's got to be a slam dunk, right? Like, come on, it's just making life so much easier, taking a bunch of weight out of the complexity out of the helicopter. Yeah, why not, right? Why not do it?
Well, and why would it have taken this long? I guess is kind of how it feels to me as a, not a rotorcraft expert by any means, but like helicopters have been around for a long time.
True.
Like this doesn't seem like a revolutionary idea. Like why did it take so long?
On the motor, I think it's related to the motor side. We're seeing that with all the electric. You got to get to the point of having a very compact, high energy density motor because you don't want to add a bunch of dead weight. Motors are, in terms of what they're constructed of, they're mostly copper, right? Copper is a heavy material, so they tend to be heavy. So you can't get away from that so much. You can just try to make it denser and try to reduce other stuff. So motors over time have gotten definitely more compact. There's a lot more electronics to control them and to make them more controllable speed-wise and for a lot of different things. So it's sort of part electronics, part motor design, and getting it where you can get it compact enough you can shove in a tail rotor. I think that's what it has been. Conceptually, making an electric motor and putting a propeller on it are pretty straightforward things to do, right? But yeah. I think it's just this is probably mostly a result, as you can well imagine, of all the automotive electric motors that are going on. That just the technology's gotten better for that kind of thing, and the cost has come down, so it makes it make it possible now. So a lot of times the aircraft market leads the automotive market, and I think in this particular case, automotive market is leading the aircraft market.
All right, for our final segment today, we're going to talk about Uber Elevate and Uber Air. So they've released a 19-page PDF sort of outlining their plans for the future, lists a lot of authors and contributors, and it's interesting for sure. But Alan, this to you smells a little fishy. Is that how you would maybe characterize it?
Well, in aircraft, it's sort of it's the new frontier. You get a lot of that talk. And
rah stuff, yeah.
Well,
we're gonna change
we're going to change the world.
The way everything's,
Right, and aircraft still have that allure of being the coolest, neatest thing, and it's just like SpaceX, right? It's the same sort of thing, but SpaceX is actually doing it, and
Hmm.
Uber Elevate is in a different mode where they're not really designing the aircraft, although they're sort of supporting the aircraft companies to develop different varieties of these things. That's trying to create a marketplace where these aircraft are developed in, but there's not so much activity going on there as I thought there would be. And I want to read one of the paragraphs in that presentation they put out the other day because I think it was just fascinating because I couldn't discern what they were even talking about. It says Uber Air is just one part of Uber's vision for a holistically sustainable transportation future that serves cities around the world. Our objective at Uber Elevate is to build long-term engagements across the UAM ecosystem steered by shared values and organized around accountability and continuous communication to inform and support the creation of sustainable UAM networks. Working closely with communities and local governments is particularly important to ensuring that the benefits a UAM has to offer are fully and equitably achieved. I don't know what that means. I have no idea what that means. And I'm a person that's been in aerospace a long time, and I've seen a lot of things coming in and out of aerospace, and a lot of sort of shaky things come in and out, and that makes no sense to me. What are they even talking about? Are they talking about having airports? Is that what we're talking about? Are we talking about equitably achieved what? How about this? If you want to make an aircraft as a taxi, an air taxi, how about building an air taxi? Let's do that first. Let's get the aircraft built first before we start changing the world, because the problem has been for the last 40 years is we haven't been able to build the aircraft to change the world. 737-8 is not changing the world. It isn't. Right? The Airbus A380 didn't change the world. Didn't. Where we had that world-changing aircraft in the last 50, maybe 50 plus years. We just haven't, especially on the small end. The Cessna aircraft, that the single engine piston airplane, that's been around since the 1950s. That hasn't really changed all that much. The Bonanza is in the 50s or late 40s, early 50s. So those aircraft are 50, 60, 70 years old. We really haven't changed anything at that fundamental level. The latest, I would say the latest achievement has been like the Cirrus SR-20, SR-22, and some of the Diamond aircraft. They've been up in that forefront just because they're composite, not metallic airplanes. But what are we doing as an industry if we're not focused on building that aircraft? Because none of this happens without having an aircraft that's even viable and a company that can make them and make some money off of them. None of this will happen. All the advanced, I can fly from Los Angeles to San Francisco or whatever they want to do, will never happen without not having an aircraft that can actually accomplish it. So it doesn't. Am I missing something here, Dan? Is there more to this that should be connecting? Because it seems like a lot of glossy photos and fancy pictures of important people, but that doesn't build airplanes.
Yeah, it's a very buzzwordy PDF. Like there's one page that says using data analysis to target and inform initial community outreach. And they're basically talking about how they're making sophisticated modeling tools that can help us identify and evaluate different configurations, and they're trying to predict demand, and humans aren't that good at predicting demand. And I don't know how you predict demand for air taxis. Like you get the first one, like we can't even predict how many people are going to take the coronavirus vaccine. We have like no idea.
No idea.
I mean,
right?
And then to say like how fast are we going to adopt these brand new, it just seems like there's just a lot of pie in the sky stuff here where, like you said, they're kind of putting the cart before the horse, where we don't know if we just genuinely don't know if there really is a market for this air taxi stuff. We just don't know.
You don't know. Does it have that Tesla feel to it? But Tesla was a totally different thing in that sense that Tesla was going to build a car regardless. Whether they could make it as a company or not was a result of building the car. That's the first step. Whether there's an eco infrastructure for electric vehicles, well, that has to come along with the car, but the car is the thing. That's the starting point. If the car is no good, the rest of it does not matter. Right. And I think that's probably the point we're missing, is you got to get to the car. Now, the thing about watching that eVTOL industry develop is there's going to be winners and losers here. And I was doing a little more research, and I'm keeping tabs of how the companies are doing. And you see the engineers kind of float around and watch who's going where. there's one part of this I think it's going to be very hard to beat in terms of a company. And I think the Heavy Side by Kitty Hawk / Whisk has this feature, and so does Joby, which is they basically tilt the motor up for vertical flight, and they mechanically bring it back down for forward flight. That feature by itself is going to set those companies apart, because it's the most efficient, probably the most efficient design they can ever have. You want to get to forward flight as fast as you can. And aircraft that have propellers that are just stationary, like they're just for vertical lift and you shut them off for forward flight, is dead weight.
Yeah.
It's either got to help lift the aircraft or we don't need it. But I think those two companies really have an advantage. Now, the Heavy Side, that's the worst possible name for an aircraft. And I understand where it comes from. I get all that. But you never name an aircraft Heavy Side.
It's like, you don't call your girlfriend fat, you just don't do any of that stuff. Yeah,
you don't do that stuff, right? It's going to be light and nimble. That's what the whole aircraft industry is about. But I will say this, the Uber Elevate conception is, I think, and then the argument is an air taxi. That's all great. Because here's the thing about that smaller aircraft market that is just so frustrating. And I listen to a lot of different aircraft podcasts, and the ones that are sort of pilot specific, a lot of the aircraft podcast talks about crashes of small aircraft. So they're just reliving the crash. And it just over and over. And if you listen to it enough, it's just like listening to an obituary. It's all that it is, and at some level. And I understand why they're doing it, because they're trying to make everybody else aware, like, don't do this. Right? But at some point, we have to have technology that gets us out of the don't do this, where the pilot can't do that. The pilot can't fly into the side of a mountain. The pilot can't fall asleep, because it doesn't matter, because the aircraft will take over and get you where you want to go. I think from an industry standpoint, we need to stop having the crashes, which are mostly pilot related. Vast majority are pilot related, not mechanical issues. So is there a place for the eVTOL market to make aircraft safer? No doubt. So much safer. It's going to be so much safer to fly one of those than it will be to fly a Cessna 182, just because the technology is better and the safety features are better. But is Uber Elevate going to do it? Probably, maybe. Or is someone like Joby going to do it? Yeah, I think they got a pretty good pathway to success.
Well, it also just seems, from my point of view, that the first thing would be like, let's build a plane that has a legit commercial market, like we talked about in our wind turbine podcast. Carting people from, the port over to an offshore site, to an oil rig. Like, why don't you just sell 1,000, aircraft to do that job and do it really well for a bunch of years? Right. And then say, hey, this works. We've proven this out. We figured out a lot of bugs. This was sort of like our beta testing. And now maybe we should build some airports in a city. And this can actually work. We figured out a lot of these bugs, rather than let's try to start by saving the world. And that's the wrong way to go. That seems crazy.
History has proven that, right? And Eclipse Aviation popped up again because years ago, back in the 2000s, they were going to build, 3,000 aircraft. And I think they ended up building 150, 200 and ended up going bankrupt. And that company went through bankruptcy again a week or so ago. But we've been down this pathway before. They're going to have this world-changing aircraft, and they couldn't make the aircraft, so it all went. No one remembers it. You ask people today what it was, Eclipse Aviation, they don't have any idea what you're talking about. That wasn't that long ago, right? And you'd hate for some of these other aircraft companies kind of get in that mode of, hey, we're going to change all the world. No, you will. If a great product, we'll do that. But let's get the product figured out first and get it flying, and then get to changing the world, right? One step at a time.
Yeah.
One step at a time.
All right. Well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.